this video, we will see about the time value of money. So what does mean by time value of money? We know money has time value, and we say that the rupee now is worth more than the rupee in the future. The relationship between the value of a rupee today, okay, value of a rupee today and the value of the rupee tomorrow, same rupee or future. This is known as this difference is known as the time value of money. So, amount invested today has more value than the same amount invested at a later date because it can utilize the power of compounding. Because money, okay, compounds. The interest, okay, reinvest itself. Compounding is a process by which the interest is earned on interest. So, the principal amount is invested, the interest is earned on the principal during the first period of the year. In the second period, the interest along with the principal will be subjected to the interest. So over the time, this reinvestment process, okay, helps you to grow your amount significantly. So let's take a simple example that we have two options. Option A is to receive rupees 10,000 now, and option B is to receive the same rupees after 3 years. Which option we will go for? Obviously, we will choose the first option instead of waiting for 3 years to get the same amount. So the time value of money demonstrates that it is better to have money now than later. So the reason is very simple. So let's say we have at the okay, this is a time, this is today, and this is in first year, second year, and then okay, this is okay, let's say third year. If you take option A, if I have 10,000 and if I invest this 10,000 now, then I will be getting interest in the first year onwards till the end of third year. So at the end of the third year, I will be having rupees 10,000 plus certain interest. But in the case of option B, I have to wait and then I will be getting in the future some 10,000 rupees. Okay, this 10,000 rupees, if I bring it to today now, its value will obviously be lesser. So 10,000 minus the interest rate. So it is discounted. So that is the reason why it is better to go for option A. So let's take another okay, simple example. Um, let's say for the first option, wherein we had okay 10,000. If the annual rate is okay 5 percentage, then the future value at the end of the first year will be 10,500, right? Because 5 percentage of 10,000 will be 500 rupees, so we will be getting the principal plus the interest at the end of the first year. So the future value um, can be calculated by this simple formula, if you would say. So which is equal to S is the amount and P is the principal amount and R is the interest rate, and okay, this is how we can calculate the future value. So how is the time value of money computed? Time value of the money can be computed in the following okay circumstances. So we can calculate the future value of a single cash flow, that was our previous example, and also we can calculate the future value of an annuity. We'll see what is annuity later. And another thing is we can also calculate the present value of a same thing, single cash flow. And also we can calculate the present value of an annuity. So let's see each of this, okay, one by one. First is the future value of the single cash flow. I already gave one example for this. So and I said it can be calculated by S is equal to P into 1 plus R for 1 year. If it is for more than 1 year, then I would say future value equal to present value into 1 plus R to the power of T. So where R is interest rate and T is the time period for which the compounding is done. But this is only for discrete intervals, like wherein the interest is calculated maybe after a year or maybe semi-annually, once in every 6 months or once in every 3 months quarterly, or it may be monthly. But what about, okay, if the interest is being calculated every second, okay, continuously the interest is calculated every second, every minute, then it is very simple. Future value is equal to present value into e power r t, where e is the mathematical function called exponential. Exponential is a is a continuous function, and the value of e is 2.7183. So it is actually a logarithmic series, natural logarithm. That's why we are taking uh, this thing, exponential series. The money grows in a logarithmic way. That's the reason why we are multiplying it with the logarithmic factor. Now let's calculate the value of a deposit, that is rupees 2000, which is made today. Okay, 3 years hence, what will be the interest rate if the rate is 10 percentage? So there are two ways I can calculate. One is the discrete compounding. This is what we will do mostly academically. So the future value is given by, yeah, 2000 into 1.10, because 1 plus r to the power of this thing. It will give us around 2662 rupees. But in the case of, okay, continuous compounding, let's see how, what if the same money is continuously compounded every second, like in a logarithmic way. So then it would be 2.7183 to the power of 3. We have to multiply this with the rate because it is RT. So this will yield around 2699.72. So around 33 rupees we are gaining extra in the case of continuous compounding. It does make sense when the money is, okay, huge. So now let's see the second part, which is the future value of annuity. So annuity is a stream of equal cash flows. So every year, let's say like I'm depositing in the year 1, year 2, year 3, year 4, year 5. I'm equally depositing, let's say 100 rupees. Then 100 is the annuity. That's why it is called a stream of equal annual cash flows. So this is actually given by the formula. Okay, future value annuity. We'll calculate like this, right? Cash flow into 1 plus r to the power of t minus 1, and it goes cash flow into 1 plus r to the power of t minus 2. So it goes on till, okay, the last or t minus t, which is will be equal to 0. The factor will be 1 plus r factor will be 0. The exponent will be 0. So ultimately we can simplify this series into this formula: 1 plus r to the power of t minus 1 by r. So here this term, okay, this is called um, interest factor, which is future value interest factor for annuity, or I would say like future value annuity factor also. So this, let's say, let's understand this particular, okay, future value of annuity with example. Suppose let's say like you are depositing 3000 rupees annually in a bank, okay, for 5 years, and the deposit, okay, gives you some compound interest of 10 percentage. So we want to find what will be the, okay, future value of this series of deposits at the end of 5 years. Assume that each deposit occurs at the end of the year. That's very important thing. At the end of the year only the deposit occurs. So the future value of this annuity is given by this formula. You just put 3000 multiplied by, I can do like this also, plus 3000 into 1.10 to the power of 3, and so on up to 3000, where the last amount will be. So if I do this, it will be around rupees 18,315.30. Or I can use this formula also. In this case, what I will do is I will just put 3000 outside, and then inside I will put 1.1 to the power of, okay, 5 minus 1, and this whole factor has to be divided by the rate, that is 0.110. Again, this will give me the same amount, is 18,315.30. So this is how we will calculate the future value of annuity. Now let's see how to calculate the present value of a single cash flow. So we already know, right, future value equal to the present value into 1 plus r to the power of t. So now this present value is simply calculated by present value equal to future value by 1 plus r to the power of t. So this is actually discounting it. Whatever amount is there in the numerator, it is discounted by this factor. That is why it is called discounting rate. But in the other case, it is getting multiplied, right? In the case of future value, this factor is getting multiplying this amount. So instead, is called this multiplying factor is called compounding rate, whereas this is called discounting rate because it reduces it. So let's say like we have some 5,000 rupees as of now. No, let's take like this. This 5,000 rupees is going to be paid to us after 3 years by some guy. Whereas the discounting rate is 10 percentage in the market. Then what will be the money? What is the worth of this money today? If I get a 5,000 rupees after 3 years, what is the worth of the money today? The worth of the money today is 5,000 divided by 1.110 to the power of 3. So the worth of money today is 3756.57 rupees. So this is in the case of, okay, discrete discounting. But in the case of continuous discounting, you can divide the same 5,000 divided by e power rt. That is e power 0.3. In that case, the amount we will be getting is rupees 3704.0911. Again, that is a significant, okay, difference of money. Around 50 rupees we are actually losing in this case. And that's why, okay, banks charges interest rate for the amount of money which you are going to repay later to cover up this loss. So let's see about the present value of the annuity. present value of annuity is the sum of present values of all the cash and inflows of this annuity. And again, I can calculate by this formula. That is the future value cash flow I will be getting delta 2 multiply like this 1 plus r to the power of t minus 1 divided by r into 1 plus r to the power of t. This is how I will calculate. The formula is quite complex. So this factor is called present value interest factor for annuity or PVF, IFA. There are actually tables wherein we can calculate directly this present value annuity factor or compound value, future value annuity factor. Hmm. This is applicable in the case of discrete intervals. In the case of continuous intervals, we have present value annuity is given by future value divided by 1 plus 1 minus e power minus rp divided by r. So there is something called effective annual return. Usually, right, usually when while applying for a fixed deposit or a bond, it is stated in the application form that the annual return on investment is 10 percentage, but the effective annual return mentioned is something more. Maybe it could be maybe 10.38 percentage also. And why this difference? Essentially, the effective annual return accounts for intra-year compounding, and the stated annual return does not. The difference between these two measures is best that can be best understood. Um, let's say let's take an example and we can understand this thing. So suppose the stated annual interest on a savings account is at 10 percentage, and we have put around 1,000 money into this rupees 1,000 to this savings account. After 1 year, the money would grow into obviously 1,100. But if the account has a quarterly compounding feature, then the effective rate of return will be obviously higher than 10 percentage. After the first quarter, um, your money would grow by 25 rupees, right? After 3 months, your money would grow into 25 rupees. The reason is very simple: 10 percentage divided by 4, you will get 2.5 percentage. So the amount that you will be getting is 1,025. Then in the second quarter, the effect of compounding would be apparent. Yeah, you would receive another 25 in the as interest on original 1,000, but you would also receive additional 0.63 from the rupees 25 that you have that was paid in the first quarter. So yeah, obviously the 1,025 will be compounded, will be the amount you'll be getting, but this 25 rupees which you got in the first year, that also will be subjected to compounding. In other words, the interest earned in each quarter will increase the interest earned in the subsequent quarter. So by the end of the year, if you do this process continuously, you will be getting around 1103.80 instead of just 1,100 which you had actually seen. So the effective annual interest rate, if you could say, it is actually 10.38 percentage. The difference of 0.38 may appear insignificant, but it is a huge amount if
the principal money or the base money is millions or crores. This is what actually I want to convey in the effective annual return. And that's it. Thank you for watching this video.